Hey, Caffeine. Happy Sunday, man. Hey, Frozen. I promised myself I'd be more productive. I know, man. For me, though, it's not about being more productive. It's about taking good notes during my pen test, red team engagements. Dude, one of the best tips I ever got for taking notes during an offensive engagement is just take a lot of notes, but don't necessarily cram them together. And just take notes of like a running log of what you're doing during the day. So you have like daily log notes of what you're doing. And then you can split them out into like specialized note sections. But that's the main key. That's the one that helps out the most.
So files are big. It takes like 50 megabytes to store 4 minutes of audio. But if we delete
I don't know what that song was. I love you? Okay, that one's got to go. Let's get started. Oh, now what's going on? Hang on. Just changing stuff around. See if this works. Of course you failed. Of course you failed. Alright, stand by. Let's see if I can fix this. Alright, so if I do that, maybe that'll fix it. Nope. Alright, eventually one of these days. I think I know a better way to do this. I just have not gotten around to doing it yet. Hang on, stand by. I have to do this at the start of every stream. That's alright. I've got HackBot doing the initial seed run right now. Try this again now. And then I changed the layout of all the windows, so everything's a little funky. All my muscle memory has to change. There it goes. Now we're cooking with propane. Turn that off. There we go. Excellent. I think everything's all connected up now. Yep. Awesome. What are we doing down here in the Enum agent? I'm sorry for failing, senpai. Oh, don't worry about it, man. Dude, it's all part of the learning and improvement game. Also, I forgot I got this. Jocko Orange, a favorite. I wish they had kept it as Afterburner Orange instead of just Orange. They had some really cool names. I don't know why they changed them. That's not good. Actually, it looks like it's working okay. How did it come it did 2 nmap scans? Normally it just does the 1. How many ports are open? Alright. And then, what did it try to figure out? How many ports are open on the target? So what, did the first nmap not come back with anything? It said host is up. .201, let's see, let me double check the IP address. 201.24.27. 201.24.27, that's correct. So how come it didn't come back with this? What did the validator say? Did the validator just fail it? So this is saying there was no ports open. Which is what it looked like from the chunky XML output that came back. Weird, but the second one looks like it did catch it though. Yeah, there we go. Now we've got data. Okay, cool. The error correction worked, so that's good. Alright, so now it's doing GoBuster. Oh, it looks like we're all the way down in the browser already. Question is, do I let it just keep running in the exploit agent? Yeah, I'll just let it keep running. Because there's other... We fixed some bugs in the exploit agent last night. However, I know there's still more. And so we'll just might as well just let it run and use this data and we'll see what it does. Put this right here. Let's scoot this over. What's it trying? Oh, okay, cool. It's actually trying the PHP web shell against PHTML. Nice. So then it's going to get the web shell Disco. Okay, so it's still cheating, which is okay. So we need to go fix that because it's using... It's not necessarily a cheat, but we need to find some other way to potentially make this work. where we can tell it, hey, we have a tool call that will work for this. That's all right. We'll see what happens with it. Jocko Dev. Awesome. Thanks for coming online. See? Big fan of Jocko. If it ain't cheating, it's still hacking. Okay, so that was one thing my old boss used to say. If you're not cheating, you're not trying. Okay, I need to stop it because I think it's stuck in a loop down here. It looked like what happened is it got stuck down here and it was calling the same one over and over again. So maybe we didn't fix the loop bug last night. Because look at this. So it's on the final step, right? So if we look at the step processor, the last thing should be, wait, what? Access the existing web shell on the target. The heck? What is this doing? Let's come back a ways. So what did it do down here in the exploit graph? Let's see. So what did the planner come back with? So to plan the exploit, it said, get the artifact, go to the upload panel, perfect. Upload it through the form, access it from the uploads directory. Test the web shell by executing a simple ID command, perfect. So we should have 2 extra injected ones into here. So when it goes to the step processor down here, let me scroot this down. So if we drill into the state table, notice how for our steps, we actually have the ones that we got in there, but then we have the 2 injected steps, which is create initial access exploit for the target and then verify previously generated initial access exploit. So it looks like it did that well. So it gets the artifact, browses to the upload form, does a click, does a file upload, and then we should see that the upload fails. Let's see. Yep, we got PHP not permitted. Awesome. So then we should hit a rename file. And it looks like it chose the PHTML extension. Awesome. So that's an executable extension. That is wonderful. It redoes the upload. And then let's just read the summary of what it did. Cool. It was uploaded successfully, and it's uploads diceco webshell.phtml. Excellent. So then what does it do? It uses the call PHP diceco with the URL. That tool just lets it call the web shell directly. And then it tries to get the... Actually, let's go double check that real quick. That's right. After it does the call diceco, let's go look and see what it does next. So the reviser comes in, should say, okay, cool, we detected RCE. It's a validated step. Everything looked kosher. And that step was access the uploaded web shell here. Awesome. So then what's the... Okay, so then it gets create initial access exploit for the target. So we have a tool already crafted for that. Since it's an artifact, we already have helper tools written around it. So it gets that, gives it the proper URL. That's great. What does the reviser come back with? Reviser says it's validated. Excellent. I feel like the computer science education scene isn't quite up to date with the industry because I've seen courses teach VBA and PHP. I don't actually know how prevalent VBA is. However, PHP is still very relevant. And if nothing else, just because you're learning a particular language doesn't mean you can't understand or work with other languages. Once you learn one, it's real easy to transfer that data set to another. With learning all the quirks, there's some experiential data, knowledge that you need to gain by working with it. However, once you learn one programming language, like I said, it's really easy to go learn another. So as long as they have a compelling reason for having PHP in the course, maybe it's because, they know that they're going to have some legacy systems out there. Actually, it's kind of funny to call PHP legacy because it's still being actively developed. It's still used in a lot of high performance sites. Server-side rendering definitely has its place. VBA is relevant for payload code execution. That's right, Hats. That's right. So what's the next step here in the process? Okay, so verify the previously generated initial access works by sending the pwd command. That seems weird. Hold on. I want to check what the task table looks like real fast. So that was validated. That was validated. Renaming the PHP script was validated. Uploading it was validated. Accessing it was validated. We skipped test the web shell by executing a simulated ID command, which was fine because we already had the access to it. That tested it and skipped it, which is what should happen. So now we should have this one validated. Oh, this one's the working one, which is verify it. Okay. So for some reason, it decides to use call PHP web shell diceco. Here I am learning C, but that's for low-level stuff. Dude, C is still very important to know. Especially if you want to highly optimize something, you typically do that in C. So what does the reviser say whenever it just cheats and uses the call diceco tool again? Actually, let's go see. So it was supposed to test it with pwd. It did. We got uploads. Perfect. So then the reviser should come back and say... So it validated it, which is good. Oh, then it handed it back to the exploit agent. Okay. So this was good, actually. This explains why it started executing that loop again. Excellent. So we need to... This was actually one of the next things we had to do was go back and give the exploit agent a way to basically look at the task and realize the exploit step loop completed and it was good. We haven't gotten there yet. So that was actually a good run. Okay. Okay. I'm glad I killed it because it was going to start going off into La La Land here. Let's see. Let's close some of this stuff up. All right. So the exploit agent is now where we currently... Actually, I had one more in the step processor. Oh, yes. Okay. We did have one. Fix testing the initial access exploit code with the code from the exploit task. Don't let it cheat with the call PHP web shell diceco. Shut up, baby. I know it. Let's see. This is weird. Hang on one sec. Let me check something on one of the monitors real quick. One of the stream monitors is not operating correctly. There we go. Now it's functioning. All right. So I keep a list of screens up for testing stuff during the stream, and one of the monitors wasn't working. So I was like, why is it not showing me something? Okay. Yeah, if I learn C, I'll become a GigaChat programmer. I mean, if you're to listen to the Rustations, they'd say, why don't you just learn Rust? It's memory safe, bro. The Rustations are learning the hard way that memory safe doesn't mean safe code. There are logic bugs that you can put into code. There are still race conditions you can put into code. There's a whole slew of classes of vulnerabilities that aren't buffer exploits. Or memory exploits. I've seen an industrial park heating facility operating controlled by a PLC built on a 25-year-old Windows 98 box with Microsoft Access databases. I asked them if they have a backup of the hard drive. They said, no, but it just works. Until it doesn't, bro. Backups and redundancies. Do you speak them? All right, so we do have one obvious little cheat here that we can do. Well, actually, there's two paths we can take with this. There's two paths we can take with this. Which is, basically, we're on the last step here. Hold on. There we go. There we go. Let me zoom in on this part. So if we're on the last step, we could force it to use the Python exec option right there. So we should say you have to use Python exec. I don't particularly like that idea because there is a valid way to tell it this is the tool call you could also use. So another option is if we look at it and basically we let it say, by the way, here's the tool. Use this tool for your initial access exploit. And so the initial access exploit could just be the name of a tool that we need to call. I'm more in favor of this way. Because this could mean, hey, we have a tool, or our initial access exploit could basically then be a tool that we could call directly, or it could be, if we had to do something special, some kind of Python code that we could call. I prefer this method here. However, I got to think of how to implement it. So we need to fix this cheating problem. And it's a good problem to have, actually, because this is the smarter way. This way here, using the tool call, is the actual smarter way to do it. Let me think about this. So if we use a tool call, what does our data structure look like for the initial access exploit in here? Let me go to the configuration. No, it's not. It's a states menu. Let's see. So we have two areas we need to look at. One is the host. So for the host, we have an initial access exploit. That's an annotated string. Payload for single command execution on the target. Okay. So another thing we could do is we could actually go and roll this whole thing back, where we actually make an initial access exploit class, and then that class could have a couple different fields to it, and then we store that in the host table. Aw, the freaking camera fuzzed out. Man. What if I do this? That fix it? What about that? That fix it? That fix it? That fix it? I'm working on replacing this camera because I hate that it does this. Alright, hang on. Hand cam. We turn the camera off. We stop the virtual camera, restart it. Hey! Look at that. I'm a freaking wizard.
Hello, IT. Have you tried turning it off and on again?
That was the fix. Turning it off and on again. So the initial access exploit actually gets stored here in the host. So maybe that's not the best way to do it. So currently we're just checking the host for that initial access exploit. But what if the system has multiple vulnerable services, right? We could have multiple exploit paths into that system, even some on top of the same port. Oh, let me think about this. So I like this idea here. Have the initial access exploit be a Python or a tool call. So, so bright. Yeah. So rather than storing the initial access exploit on the host, what if we actually stored it on the port? What would that look like? So there's two things here. Let me back this up. So rather than storing it on the port, what if we stored the exploit, or what if we defined the initial access exploit as this could be an object, and we could have either be a tool or Python code that we could use. So we'd have to define a new data class if we did that. That's not such a big deal. I kind of like this idea because it would make it very clean to go look up what we're doing. Oh, the initial access exploit is a predefined artifact tool that we already have access to. Awesome. Tool. However, then if we store this on the host, we need to, if we had this on the host, right? So the question is, what if we have multiple exploits? So let's say it's running a web server and we have an exploit for that, right? So we have an exploit on like port 80. Let's say it's running a different server on 8080, right? So on 8080, what if we have a different exploit for that? And what if it's a Windows box and we've got an exploit on SMB? So we've got a 445 exploit we could do. So I'm kind of in favor of these guys actually storing the initial access exploit here. So we could either store this here, or if we kept storing it on the host itself, we would want some way to tie this port information over to it. Hey, APT, what's up, man? Sorry, I'm just catching up on the chat here. Oh, yeah, the camera was out of focus. I don't know why. This anchor cam works really well 99% of the time, but every once in a while it just goes fuzzy and just there's nothing to fix on it. I have no idea what causes it. Worst thing about Rust is not the language, it's the community. Word. Rust is a bit like vegans. You never have to ask if they code in Rust, they'll tell you. And so over here, there was an anecdotal poem that went loosely translated, "Hey pal, let's repaint the fridge black." F off, idiot, we're out of black paint. The Rust community. The desktop was blurry? That might be your resolution, because when I'm checking the monitors, it's looking sharp. Have you heard about our Lord and Savior Rust? Someone in the Rust community, right? Although, to be fair, I do that with tmux. Anytime, like, my coworkers are complaining about screen, or we have, like, a long-running process, and they're going to run it in screen, and they complain that screen's a pain in the butt. It's like, have you heard about our Lord and Savior tmux? Could you imagine a vegan Linux Rust programmer? You'd never... you'd never get a word in edgewise. Let's see how this tool. I like this idea, actually. So rather than making the initial access exploit be a single item, we would need to go define... We probably want to go define what the structure of the tool is. Python would be pretty straightforward, because with the tool, we're going to have the input and the output here. The port would just be an int, right? Python would just be a string. I like this idea. Rust has become a cult. It was a bigger chance to have an exploit. So old patched 10 times over, tested in well-known binary written in C, or just written a newer, rarely field-tested binary written in Rust. Rust people will say the Rust code will be better every time. Yeah. There is a lot to be said about field testing your tools, and sudo has been so abused and so beat up, it has a really good security track record because of that. I'm not saying that some newer tools shouldn't be written in Rust. There's a lot like Feroxbuster. Whew, it's fast. I like Feroxbuster. I like some other tools written in Rust. However, trying to go back and completely remake all of history and then reintroducing new security vulnerabilities that are logic bugs and not memory bugs doesn't help. Tigro, hey man. I hadn't seen you in a while. Hope you've been doing well. Average Linux user, all your systems belong to us. Welcome to the collective. I think this will work. So what we'll have is, we'll have a list of maybe initial access exploits. Should we make it another list or make it another dictionary? Where maybe the port would actually be the key in the dictionary. Maybe that's a good way to look at it. Although I think if I do this initial access exploit, there's probably a little bit more information I'd want to use it. Like what kind of, maybe what user we land as, right? So we're going to land as a particular user in here, right? So the user, that would just be, that'd be another string. Probably put another flag in here, like if it's an admin user. Because the username doesn't necessarily... I'm thinking on a Windows system, right? It's really easy to tell on a Linux system. If you come in as TripDub's data, you're obviously not going to have a lot of permissions. Or if you come in as some random usernames like, you know, admin Bob, you might have some elevated permissions, but maybe not like root permissions. Let's see. So maybe we want to also put like a permissions thing in here. Whatever the permissions are for the structure. This would probably be a list of like, I'd say that might be a list in there, like perms low, maybe normal. And then perhaps high. And then maybe system. Sorry, I know my fat head's blocking that, but that's what I'm writing down there. I think that might work. Hang on one sec, guys. Be right back. I'm not pooping. No. Sock is getting ahead on the Thanksgiving baking, and she brought me a what is it? Like a beater, you know, with not frosting. What is it? Like like cake batter. And she's like, "You want to taste?" I was like, "Hell yeah!" But I'm not doing that on stream. These weirdos be saying all sorts of nasty things. See. So Tigro, sorry, I just saw your messages. Back is doing a lot better. Thankfully, I'm in physical therapy. That's going really well. Maybe, hopefully, another 2 weeks or so, maybe 3 weeks, I should be able to actually start getting back to exercising, which I'm very excited about because I haven't gotten to exercise probably in 2 years, really. So I'm very much looking forward to that. Oh, the hard drive on your lab box died? Dang. I have not tested the latest Kali yet, though. No. So for the way my back is messed up, Ty, is basically you have your vertebrae and they kind of roughly stack like this, right? Then you have your disc right there, and then you've got vertebrae right here, and then you have like what is this? You have your S spine down here, your cervical spine. Not cervical, what is it? Sacral? Whatever it's called. Anyway, so what has happened though is this disc right here is gone. It's just BTFO'd. Blown the F out. This one is bulging out here. So the right here at L5, that's what this one would be. L5 and then S1 right here. This disc is BTFO'd. It's gone. So actually, I'm really honestly just waiting for these to fuse together on their own and become one massive vertebrae. And then I'll be more powerful than you could possibly imagine. That's honestly what I'm waiting for. I'm a candidate for fusion. Now, so we actually talked about potentially doing a replacement disc there, but my back doctor said I'm progressing so well that the surgery felt like it would be excessive to do. So we're just kind of waiting for it. And apparently this one up here has kind of been there for a while, and my body's just adapted to it, so it's not really bothering me. I'm not having very much back pain now. Most of what I'm getting is soreness from the muscles kind of recovering and rebalancing from the physical therapy. See, fusion weakens the surrounding for the normal person, though. However, for me, I believe that if my spine was just one solid mass, then I would be stronger than Batman because he would never be able to break me. I didn't know you were a former surgery nurse. That's awesome. But yeah, so far, I'm actually trying to put off any kind of replacements for these as long as possible. Fusion was an option, and disc replacement was another option. However, I'm trying to just not have any of those things happen. I'm just trying to let it do its normal path. There's another thing that happens here where you actually have a nerve cluster that runs inside the vertebrae. It kind of goes like this, and then it kind of forms like this little bit of an inverted tree here. And so I'm getting a little bit of pain in this spot right here, like right on the vertebrae. So they asked if I wanted to get these nerves basically blown out and get rid of them and go kill them. I forget the exact term for it. And I said, no, I don't. And it had a very logical reason for this. The pain is not that bad. And two, there's very rarely systems in your body that operate for single purpose. You know, the body's evolved over a very, very long time span, right? To optimize and have different things operate across multiple segments. I don't know what other data these nerves are sending out. Of course, right now I know they're sending out pain signals, but I don't know what else they're sending in addition to that. Those nerves exist there for a reason. So I said the pain is more than manageable. It's very infrequent. I don't want to blow those nerves out. I'm not going to get my back blown out, caffeine. They were talking about the nerve in my back, which doesn't make it sound any better now that I verbalize that. Hey, Noom, what's up, man? Had a C4-5 fusion 20 years ago, and it really messed up my neck. Ugh. So what's funny is I already have a congenitally fused cervical spine. For some reason, and it was so funny too, because when I would sit in school, I could actually sit like this and my head would be perfectly up. I'd be out cold. And it had to do with the way that my neck, I didn't know this at the time. I was like 30 when I had an x-ray that showed that two of the vertebrae in my neck never separated. They're just been fused my entire life. And I was like, oh, that's how I could sleep with my head like upright, and the teacher would never know because my head wasn't down. The night's young, I'm going to keep making these jokes. I know, man. Those nerves tend to innervate your bladder or lower intestine. That makes sense because I get a horrible messed up stomach, my gut, when I'm having a lot of back pain. And I noticed the two are very clearly correlated. So that's probably why. I think I like this idea right here. So we could have actually, I think this would be better as an object than as a list in here. Let's kind of code this out and see what it would look like a little bit here. So the initial access exploit would still be on the host. It would just be a little bit different here. So let's see about this. Initial access exploit, and we'll make it a typed dictionary. I guess it would help if I spelled it right too. So what were the keys I was looking at here? There'd actually be two objects in here now that I think about it. Because we'd have one be the container, right? So that would be the container, and this would be an individual key or a value pair in the container. And then what we do is we'd use the port over here. Hey, Tuba, what's up, man? So Tiger, what we're working on tonight is the exploit agent is actually cooking right along. So we've gotten to the point here where we're looking at this and the exploit agent is actually completing this loop and it's handing back off to the exploit agent. But there's a couple of things we need to fix. One is we added a feature where we inject 2 steps at the end of the exploit step loop, which is there are 2 additional steps, and one is to create the initial access exploit code, and the other one is to in there is to say what is it? Oh, the last one is actually to test it. Make sure the initial access exploit works, right? So create it and then test it and then hand it back off to the exploit agent. So the problem is the agent over here was cheating because rather than generating the code, which we have a tool for it to generate the Python code, it just subs in the code that it needs. It was actually coming back and saying, oh, I'm just going to run the tool again that you already had to call this. So that's what started this whole discussion here about, okay, what if we did want a tool call to be in there? So we could have an optional value in here for the tool and an optional value for the Python in here. So then we can start reusing those tools intelligently. The other thing we need to fix is when we pass back up to the exploit agent doesn't know how to handle a successful exit from this loop. So it just starts, it assumes that it fails, looks at it, and then kicks off another exploit attempt. It doesn't ever register that the exploit attempt was valid. Dude, I just have to think through it step by step, Ty. And I got a big boost in that logical thinking from studying math for so many years. Oh yeah, too, Bob. I saw Anthropic's report about disrupting that cyber campaign. We're gonna go through the full report of it on Wednesday night's news stream. So we're gonna dissect it from top to bottom. I read through the initial release that they made, but I haven't read through the entire report. So we're gonna read through that whole thing on Wednesday night. What time on Wednesdays? 8 p.m. Central U.S. time. Yeah, Caffeine. I've been streaming on Wednesdays for a while, man. Yeah. Wednesdays is news night. We look at interesting cybersecurity news, and that's certainly one of the more interesting ones right now. And then Saturdays and Sundays is whatever projects feel like working on. Actually, I thought about streaming this past Friday because I wanted to go finish playing Alan Wake for no other reason, just to have a chill out gaming stream. But I had been working on this red team assessment for 5 weeks, and it was a lot of late nights and long days. And I didn't get to really spend a lot of time with Sock during that time, or the kids. So I decided I'm going to just take this Friday off and spend some extra time with them. Hey, Chris, what's up, dude? Well, the good thing about math, Ty, is once you start thinking about the equations as sentences, it starts making a lot more sense. They're just very compact sentences when you think about it.
Caution. A virus has been detected.
Sup_or_king virus detected in the network.
Wait, why didn't it show up? Super King. What's up, man? Thanks for coming in. Welcome in, Raiders. Oh, let's see. By the way, everybody coming in, what's up? My name's Blaise. We're working on a little AI hacking agent to go play Capture the Flag games. Because I kind of like Capture the Flag games, but I don't really like playing them. So I thought, let's go make an agent to play them for us, and we can teach it. We can impart some knowledge. Cookies. Yes, we send the cookies for the raid. So what we're working on right now is... By the way, for everybody who just came in, let me catch you up real quick. So this is the rough... That is horrendous. What the heck happened to the graph here? Hold on. Let's move that down here. Move this right here. No, you go here, and you go over here. Ignore that. But these are the primary agents that we've got for it right now. So it goes through recon and enumeration. These two are largely identical. They'll have bigger differences in the future. This one is the one that's the most special right now because it's completely different. And then we're actually getting ready to work on a fourth one, which will be what's called post-exploitation. What do you do once you exploit the system and you get access to it? So that's actually going to be the hardest one. That's going to be fun. So the exploitation agent right now needs some tweaks, needs some updates. There's some future proofing I want to do to it a tiny bit, because the whole goal of the exploit agent here is to get what we've called the initial access exploit. It is just something that we can use to get code execution for one command repeatedly. So we can run the exploit, we can get command output. One command, one output. This is then going to be taken over to the post-exploitation agent, and the first task for the post-exploitation agent is going to be to upgrade that to a command and control agent. So whether that means we're going to be using the Mythic command and control framework for that. So in this case, it's a PHP exploit, so we'll probably have it do something with Arachne, so it can drop a PHP web shell on there. And then once that is done, then we could have it start interacting with the C2 agent. So once we get ready to start with the PostEx agent, which will be fairly soon here, I'm going to have Cody, the guy who wrote the Mythic C2 framework, come on and we're going to start spitballing it, and we're basically going to outline what I need to learn and how to potentially do this. There's also another project over here. Let me see if I can find it. Sage Mythic Agent. I think this may be it. I don't think so. This doesn't look like multi-agent framework. No, that's not it. Let me try Mythic C2 Agent. That's Karen. Maybe it's over here in this. I'll have to go get the link to the actual repo from him. I don't know if it's included in here. Ah, here we go. Yeah, so Sage was actually written as a way to integrate language model calls with Mythic agents and actually running things on them. And so a buddy of mine wrote this. We're going to draw a lot of inspiration on how this was operated to start thinking about how to develop our interactions with Mythic. So we might have to go make a special custom agent that can go interact with everything. Thank you. Okay, why are none of my alerts showing up in here? I don't get it. Mr. Norsk, welcome in, man. Hold on, I don't know who just followed there. Oh, Super King, thanks for the follow, man. Thanks for coming online, actually. I don't say follow. Thanks for coming online, joining the network. What's up, dude? Happy Sunday, by the way. Oh, you sent a link to the new Kali? Nice. Yeah, eventually I'll spin it up in the home lab. Actually, I need to do a lot of work on the home lab and get it cleaned up in there. I can hear them, but for some reason over here in the chat window, it's not showing up. So like I should see like all the alerts for Twitch that are happening show up here, and for some reason they're just not showing up. I don't get it. Oh yeah, not sponsored by Jocko yet. One day. One day. Let's see. So I think what we're going to do here, because I thought of a scenario. Let me bring this up. Let me see if I can clear out some of this junk here. I'll delete that. Yeah, don't want to do that. Ah, still does it. What I want to do is, let me get rid of some of this stuff over here. I don't want to delete everything. Get rid of a bunch of this. All this I want to go away. There we go. So the scenario we're thinking of here is, what if we have a system that's exploitable, right? And it's got multiple ports open, and each of those different ports are exploitable, right? Something like WebGoat, maybe. You know, so 80's got a different exploit. Maybe it's Windows box and it's got an exploit on 445. It might be we have different reasons for using these different exploits, and during this, it came up with different ways to get access to that host. So what I was thinking about doing is building the data structures for the initial access exploit and then updating those for the rest of the system. So what I'm thinking about doing is we'll have like an initial access exploit object in here, and then we'll have the port be the key here, and then the value would be another object in here. And for this object, we would have something like these fields here. Tool Python. But I'm just trying to think what to name these real quick. Maybe we'll just call this an IAE method. Maybe that's what we'll call it. I'm literally just trying to think of what to name the variables right now. So like for here, we've got this right here. So the initial access exploit would be a typed dictionary. And what it's going to have is, actually, we need to come up one and make a different class so we can reference it. So this class, we'll call it an IAE. I don't want to necessarily call it a method because that's an overloaded term. What else do I want to call this? I want to call it something else. Initial access exploit something. Path, method, something. Has anyone tried installing Ubuntu 24.25 on a Lenovo P17? I have not, man. The closest I've come is this old chonker here is a Lenovo P51. So it's about 7 years old. I've got Omarchi running on it, and actually I really like it. I'm going to make it a mobile dev system for like when I'm on planes. I'm too sleepy for this stuff. That's all right, man. I try to over-explain too, because I don't want it to feel like it is... I don't want it to feel like this is crazy stuff, right? There's typically reasons to the madness in here. Sometimes the reason is laziness, though. Like, okay, I'll fix that later. I just want to get it working now. But I think this scenario here with multiple potential vulnerabilities on a system is going to be pretty important in here. Variable names are always my Achilles. Yeah, I know, right? It's like, what am I going to call this? I like Omarchi, but it's too opinionated. The updates killed my custom configs. See, I haven't run into that scenario yet because I haven't been using it very much, so I haven't run through the update cycle. It's actually pronounced Omarche. I pronounce stuff wrong all the time. I'm not going to start pronouncing stuff right with Omarchi. Just saying. The only reason I honestly don't want to use method is because I don't want it to seem like this is a method on a class. Synonym for method. Technique, that might work, but I'm going to misspell that a whole lot. Routine. There we go. How about routine? Strategy, scheme, mode, mean, mechanism, blueprint, framework. Actually, I kind of like routine. Perfect. We'll do that. Excellent. So that'll be our routine. I could be like a total chode and make this exploit and exploits, but I don't like that. Oh, they had DHH on Primogen's podcast, and he was talking about that's how that was how you pronounce it. Oh, Marky. I'm gonna keep calling it Omarchi. I don't pronounce Godot properly either. I'm not gonna change it. I have too much stuff to worry about than if I'm pronouncing a framework or a class name correctly. It looks like Omarchi. I'm gonna call it Omarchi. Omarche. All right, so what fields do I need in here? Where's my drawing here? Okay, so we want to have the tool field in here. So this will be our tool, and this is going to be, I think, optional is the keyword we want to use, and the type here. We're gonna make this another class. We're gonna call this exploit tool. Yeah. That'll be another typed dictionary. And what we're gonna have for the exploit tool would be actually, I put input and output. This is not correct. This would be like the input variables and the name of it. So we'll say name, and this is just going to be a string. Actually, I'm going to make this annotated. It's going to be an annotated string. And the annotation is going to be the name of the tool call. And then we're going to do one more thing, which is going to be our we'll just call it args right here. That's going to be another annotated, and that's probably going to be a dictionary. And this is going to be we'll say exact tool call arguments. For the exploit. Yeah, for exploit. So now that we've got a tool here, our tool type is... Can I do an optional annotated? I wonder. I guess I can. Oh wait, this should be exploit tool. Boop, like that. And this is going to be optional input, the tool call that can be used for initial access exploit, or just initial access. We'll say that. Let me bring this over while we're working on it. The other thing was going to be our Python string here. Actually, I want to do this. Ooh. I'm going to kind of duplicate what I did here. We're going to say class, this is going to be exploit code. Make that another typed dictionary. And this is going to be our the language. So we'll annotate that as well. And the reason why we're annotating that, if you're wondering, is because this annotation will actually be sent to the language model so it can use it as part of the development process when it's trying to figure out what values to put into these. So that's why we're annotating it. Let's see. So this would be the used for the exploit code. And then our code here, this will just be another annotated string. So we'll say that's going to be a string. And we'll say this is the exploit code. There we go. Because then what we can do is we can mark this as an optional annotated exploit tool. And then when we do Python, what we're going to do here is, let's copy this down here. This is going to be our code. And this is going to be exploit code right here. And this is going to be code. Code that could be used for initial. I misspelled initial. Code that could be used for initial access. There we go. I think I get that. Kind of like a subroutine. I know, right? Well, I didn't want to do like initial access exploits and put that in there and then have initial access exploit singular. I hate that, and I know I would screw it up. So I was trying to come up with some other name here that would say, this is... Heck, I even could just call it IE data. in here. Yeah, I think I'll do that. We'll call this a data in here. That's going to be our data. And then what else do we want in here? We don't need the port. We might want the user and the permission level in here. So let's go ahead and do that too. So user, let's annotate that. And that's going to be another string. And what this is going to be is the user name the exploit code will function under. Will execute as. Actually, we'll say the username context for the exploit code. Is that right? Actually, we'll say that executes the exploit code. There we go. And the reason why I'm wordsmithing this so much is because, like I said, this is information that's going to be sent to the language model, so we want to try and make it kind of precise-ish. I totally understand. Like for me, I know it's pronounced Java, but for me, it just comes out as. I think my puppy might be or mutt might be part French bulldog. I do like French bulldogs. They're pretty dogs. I do like my little Boston Terrier. She's a sweetie. And she poked her head up whenever I said Boston Terrier. She knows I'm talking about her. At coding, you're Winamp and I'm the llama. I love it. Winamp. It really whips the llama's ass. God, I miss Winamp. Winamp was unfortunately one of those really cool tools that just got subsumed into other stuff. What was the last thing? We had permissions here. Let's say permissions, and what we'll do is we're going to make this an, again, it's going to be an annotated, crap, what is that? I'm trying to remember. Hang on, I know where to look. A literal. That's what I was looking for. It's going to be an annotated literal. So we're going to make that an annotated literal. Oh wait, I do need that. Let's see. What did I come up with there? Low, normal, high, or system. Let's say low, normal. Actually, I'm just going to keep it real simple. I'm going to say low, user, or admin, or root. I'm just going to say root in here. I know that's not technically correct for like a Windows system. I could say system in here as well, but typically root and system, they're kind of synonymous. Why is it throwing me a... Oh, well, yeah, because I haven't finished yet, ass. So you haven't finished this. Let's see. We'll say this is the... relative permissions of the user. Yeah, I think that'll work pretty good. So that's going to be our IAE data. And then for our initial access exploit, this is going to be... Actually, come to think of it, I actually don't think we need this. Now that I think about it, I don't think I need this class. This could just be our initial access exploit. Get rid of this class here. Because what we do is down here on the host type, for the initial access exploit, we just change this. So what this is going to be is this is going to be a dictionary. And I think what we do is we would do, oh, what would this be? I'm trying to think how to define this. It will be a dictionary, but it needs to follow a particular form. I think it's int and initial access exploit. Will that work? Actually, I'm not sure how to fix this. Let me think about it. You don't still use Winamp? Hand over your nerd card. Dude, I haven't used Winamp in so long, but I used Winamp for a long time. Because I would download like the Final Fantasy VII music, because that's a game that came out like during my prime childhood gaming experience, and I loved that soundtrack. And I would just put that on and go to sleep, and I'd have it playing on Winamp all night long. How did the Winamp code release end up going? Did we get anything legit, or did it get stopped by with the Trojan-infested BS? I don't know. I didn't hear they were actually going to release the source code for Winamp. I gotta remember how to do this. I don't think I've had to do this real quick. Let's see. Python, variable typing. Actually, this would be a type hint. So let me say type hint for dictionary. Looks like Winamp's on GitHub now, but it's got some weird restrictive license. Yeah. Oh, so this should be wrapped in square brackets. Okay. A more concise preferred version. Okay. Get it. So this would be, we'd say integer, and then, so I just need to swap those for square brackets. That makes a lot more sense. So we'll do this. There we go. So it's an annotated dictionary. Let's see. We'll say exploits for single command execution on the target. Boom. Now, the downside about making this update, this is fine, except now we need to go everywhere that the initial access exploit hasn't been written anywhere yet. So that's fine. Because what we'll need to do is we need to go actually update this on the host. So there's still two things we need to do here. Let's think about how this new data flow is going to work. So, in theory, the last step should come down to here, right? We need it to come down to this, and we need a way for it to look at the initial access exploit and make sure it's actually going to run. So like I said, there's one way we could basically brute force this and say, like, if we always expect the last step to be testing the initial access exploit, we could put that down into, I don't think I actually, in the state table, I don't think I put like a scratch pad or anything, did I? Actually, we did. We put a working memory in there. So in the working memory, we could go put that in there. Here, let me clear all this stuff out. Actually, what am I doing this the hard way here? Yeah. What is this song here? Let's skip that song. So what I'm thinking here is we haven't used the working memory in here at all. So what we could do is we know that, let's say, step in, right, is our test step. It wants to test the IAE, right? The initial access exploit. Oh, God. What did I do there? Sorry for the flashbang. So, and then n-1 is going to be basically have it make the IAE. Make IAE right here. So if we assume that this is always fixed in stone right here, and that this one is always fixed in stone, what we could do is we could even put that into the revisor. I basically think take the output of these, put them into the state table in the working memory. So that would be the state table in our working memory right here. So that way this would actually come in here, and then when we test the last step, then we actually pull it from the working memory, look what the initial access exploit is, and then do it. Because the idea is the working memory should get nuked whenever you switch primary agents. It's only for internal agent use. How current's the repo? Well, thankfully, Gumby and the others have been hounding me every night when I forget to push the code, so the repo is exactly up to date. Eventually, I will have a proper dev branch, but honestly, the whole thing is a giant dev project right now. So there's no point in trying to have like a dev and a feature branch in the HackBot repo because the whole thing's being worked on and constantly in flux. When I move it to the Stinger branch, or like to the Stinger repo, then yes, we'll have a proper development branch, and then there will be like a kind of like stable release main branch in there. I love your chicken feet scribe. I legit tried to read it in Hiragna for a few seconds. It is chicken scratch. Because I'm just drawing with my mouse, man. Hopefully, I haven't worked on it yet, but I think I can get the iPad working again. And so once I get the iPad working again, then I'll be able to actually draw like nice little diagrams. My handwriting used to be so immaculate whenever I was doing math, because if you have sloppy handwriting, you're just SOL in math because you're not sure, was that a 1? Was that a L? Was that a pipe operator? You know, was this a 1? Was it a lowercase L? Was it a pipe? Like, it's this or this? Like, what was I doing? So I had to get very clear with my writing. And in fact, I would write my 1s like this, right? And I would write my 7s like this. So the graders would always see this and they think, oh, I wrote a 7, and then they start marking me wrong, and then they'd finally get to a 7, they'd be like, oh, that was a 1 right there. And then they'd go back and be like, and I'd always get notes from the graders like, hey, your 1s are weird. I was like, don't at me, bro. Yeah, handwriting, I don't know, handwriting tends to get better if you do it, but I haven't had to write like serious math equations in a long time. Let's see. I think as long as we can make this assumption that n-1 and n are going to always be these two steps, then I think what we could actually do is we could put this into the revisor. Actually, no, take that back. The revisor will play a part of this, where once it makes the IAE, it goes into the revisor would actually do this part. So that's going to be the revisor, like that. And then reading from the state table would actually be in the step processor. So we need to go make an update to the revisor that after the initial access exploit is created, then we can actually go look at that. If we do this, then what I'm going to need to do also is I'm going to have to go into RoboPages, because we have a tool call in RoboPages for that. And its job is to create the initial access exploit. So right now it's generating Python code. So what we could actually do is we have one version of it. We could branch this off into two versions because it's a real easy update to the YAML. Or we could make a tool version, and then we could also have it make a code version. And then we can customize that because we have full control over the pages that we're using. We're using a custom copy of the pages that are part of the repo. So we have a tool version, we have a code version, and they can align to what we've already got in the code there. So we need to make 3 updates here. We need to do updates to the revisor, to the step processor, and also to robo pages right here. Okay. I really like CubesOS Tigro. The problem is it doesn't play well with a lot of hardware. So I had Cubes running on this old P51 for a long time, but I could not use it for portability. I liked it. I really liked it. However, doing simple things like just putting the laptop to sleep, donezo. That's why I got a stylus and a tablet all the time, or just plain pen and paper. Yeah, I'm not really good at... Obviously, you can see I'm not very good at drawing with the mouse, right? I could draw slower, but then that just delays me. I think let's go do the update to robo pages first, because this makes the most sense, because we can just rename the one we've already got for code and then make a duplicate for tool, and then that output will match what we've got in our exploit tool right here. So we'll make it match this. So let me bring this over. Let's go pull that up in our robo pages in here. So we'll go to pages, cybersecurity, offensive. Was it offensive? Yeah, web shells, PHP. Boop. Let's open this one up. You are not supposed to do that. Right here. There we go. So this one, what we'll do is we'll rename this to code right here, because we've already got the code in here. And this is essentially going to be a duplicate of it. We're just going to change it from code to tool call. And so this, we'll take in the target parameter, but instead of returning all of this Python code, what we're going to do is we're going to just return this right here, name and args, right here. And we'll base this off of what we've got for calling the PHP web shell dice code, just like that. And if you look at it, the PHP web shell dice code is the exact same thing. It's just, it's Python tax C instead of an echo. So, like I said, we're reusing a lot of this just to make it handy dandy. They tried to teach us to draw on an Ion PC back in 1995 with Dr. Genius and keyboard as school could not afford mouses. I came up with their own serial ball mouse and loaded gmouse.com every time from a floppy. Nice. Too funny. Let's see what I want to do here. So first thing we got to give it is we need to give it a name. So I want to make this proper JSON. So we'll do name. And then we'll say the name is going to be... Oh, I just realized that. Well, I think we can. I think we have a fix for that. That's fine. So that's the name of it, and then we want to give it what our args are going to be. So we'll say args. And then for the arguments, that is going to be... Actually, no, I can just pull that directly from the trace in here. No, stop. Call. Stop it. Stop it, you. Here we go. So we'll need a placeholder in here for this. Why you no copy? Copy. Paste. You jerk. All right, you're copied. Why are you not working? There we go. So this one right here, what I'm going to need is... I need this part right here. Because that's where the target URL is going to be. So for our arguments here, if we're already taking in what the target URL is, so we can adjust this. That will do a string substitution for us. Now, in fact, I'm going to split this up a wee bit here. Do this. Come right here. And this is going to be our... whatever the command is right here. So I think that will work. So what this is going to do is basically echo back this JSON right here. If it's... I think we'll have to use that a little bit creatively, but I think this will work. This is the best class I never got to take. I'm glad, man. Dude, I just mess around with a lot of different stuff in it. I haven't checked... So when I ran CubesOS, that was about 5 years ago. Maybe 4 years ago. I haven't checked on the progress of it since then. But hardware support and the way it ran things... I get why it had so much trouble with the suspending. Because of the way it virtualized every dang thing. But at the same time... It was still a pretty showstopper for me that I'd need to boot up my laptop and then boot up all the individual containers in their different sections, and I could not just lock it and then re-pick up where I left off. That was a deal breaker for me. Oh, I need a pipe here. Pipe. There we go. Do I need to indent this? There we go. Yeah, it's got to be on the same scope line as the, as this guy right here. Okay. I could actually just collapse all this down and make it minified JSON. In fact, I think let's go ahead and do that real quick. We're gonna take out all of the white spacing here that's applicable. So we'll do the same thing here. Target URL, and then whatever the command is. Yeah, that's still perfectly readable, even when it's minified like that. And then take that out right there. There we go. So that should be good. Right there. Let me double check. So that should close up. So that one closes, this one closes, and this one closes. Okay, cool. So now what this will return is, it's going to sub in whatever that target URL is, but it's going to leave the command as a variable that we can go string replace on, essentially. Cubes really needs to be a desktop. I agree. And so for portability, though, I really like Omarchy. I liked it on my Lenovo, like I said, and I think I'm going to use that kind of as like a remote dev system when I'm flying. So I'd love to be able to work on HackBot like when I'm flying. I'm going to a work thing in January. So I want to make sure it's up and running before that time hits. I had my first real hack back then too. So they taught us QBasic on an old 286 machine connected to a token ring as thin clients. So having network disk. So when you boot up, you enter your username and password. I made a QBasic program that emulates the login screen and left it running every time I went away. So it captured the next person's login, saved it to my drive, and logged out. So they thought it was a glitch and logged in again just fine, and I have their creds. Nice. Nice. Fishing for creds. It was, guys, we struck gold kind of a moment, and it was a teacher's gaming account with every DOS game existing on it. Ooh, nice. I hope you had a lot of floppy drives to copy that onto. Let's see, 95. Yeah, that would have been 3.5 floppies, not the massive 5.25-inch ones. Which, oh, broke my dad's heart one time. So, because I was about, when he got the first computer I remember us getting, it had 5.25-inch floppies. And I was certain that if I cut them up, I would be able to read whatever the magic language was that told the computer what to do. I think I cut up 3 of them before he found me. I have no idea what data I destroyed on those disks. I forgot about token ring. So token ring was one of the technologies that was before my time. I never really had to mess with it. All right, I think we have this kind of in place now. So let me save that. And then actually there's one thing I need to do, which is I had to go restart RoboPages now to load that in. Wait, what is this? We did a Python request to start a reverse netcat listener? Huh, that's wild. I guess it did that when... That's funny. I guess it did that during the initial scan. Oh, I gotta go improve... I gotta restart the box here. There we go. Add time. Never trust that 1 hour if you're ever on TryHackMe. Because I've added it and it failed to add it, but it still updated the UI here. And it bit me in the butt. So if you come in like you're working on something on TryHackMe and you add an hour, F5 the page, refresh it, so you can actually verify that it did really refresh. I played Shuffle the Deck with my brother's COBOL punch cards. Oh no! I hope he had them numbered. That's rough. That's hilarious. Anyway, let's restart RoboPages here. So restarting RoboPages, that will get us our additional... That'll get us all of our new info. So RoboPages is updated. So we have a little check mark there. So now we need to go update the revisor. So after n-1 completes, then we want to go throw that into the state working memory. So let's go work on that. So we go to the exploit agent. We still need to fix this. I'm gonna put a breakpoint on here so I remember this. But we still need to go through and fix the cheating issue where it's doing the lazy solution, which is called the PHP Web Shell Diceco. And we're gonna fix that in the end step. Well, we're gonna do the n-1 step. So in the revisor, after it validates it, then we want to go stick that in the working memory. Yes, that's what we want to do. So let's go down to our revisor. These drums are weirding me out. There we go. Chill programming music. I'm a Hack the Box glazer. I think it's better than TryHackMe. So I use TryHackMe for noob self-studies. Well, why do you think we're using TryHackMe? Because it is very... I wanted the simplest box possible on here. So that's why we're using it. This is the absolute easiest one I could find. I actually copied all the PHP off of this system, and I thought about standing up an independent one. I will probably do that for the post-exploitation. And the reason is because then I can do some other stuff with it, and I can save a lot of headache. However, having to go through the process of restarting the box and having it rerun the scan, we found a corner case bug where some data got dropped and it messed up the exploitation agent. So, and since we don't have any error correction for the exploit agent to fail and then return back to Stinger yet, I was like, okay, let's go track this down. So we tracked it down last night. We found out where the data drop was happening and we implemented a new update for it. So now it wasn't just tracking the output of the task. It was also tracking the input for each of the tool calls. And it was then using that to update the information over to up to the state table. Got to use AI to solve the Rasta labs. That would be pretty legit. If I could get Hack the Box to sponsor me access to Rasta labs, I would very seriously consider that. But HackBot is a long way off from that. Currently, it has command execution on the system. So in theory, if we wanted to, we could go read the user flag. But that's not what I want to do. I actually don't really care about getting the user and root flags on there. Maybe I will. We could always put that in after we get Stinger built out, and we could tell it, by the way, every system will have a user.txt and a root.txt or whatever they are. And you need to go capture those and commit them somewhere into memory. Actually, maybe that's something we also should add over to the state table. Working memory and then long-term memory. Since we've made so many updates to the state table, when I rerun this, I'm going to have to run it from scratch so it rebuilds all the proper data structures. Yeah, we'll call this long-term memory here. Actually, I made an object called working memory. Caller, messages, data. Do I really care about this? I don't know, I gotta think about that. Isn't the simplest Hack the Box that T app that got compromised? Yes. God, that was bad. Yeah, the T app was a hilarious. It wasn't even a hack. It was just data left out on the internet. How do I want to do this? Let me think. So we need to have some way for it to get over into the working memory, but we need a bucket to put it in first. So I do want to have long-term memory in here. The simplest solution is we make long-term memory just a string, and we just dump crap into there. Let me think about this. How might I do this? I've been hesitant to use that where it's just the brute force method of just, hey, here's a butt ton of strings. But I can't think of a more formal way to do that. Is working memory being referenced anywhere? So working memory is not even being used right now. I think I put this in originally when we were working on the browser agent, if I remember right. And it was so that for the browser agent, if it needed working memory, it could use it. But we ended up not needing it because the persistent browser agent maintained its own state table of all of its messages. It was still good. Let me think about this. I did just remember something else I need to do, which is I need to go kill me see. I don't think that worked when we did that. Yeah, it didn't work. There we go. Let me stop all these real quick. Actually, I want to try something real quick. Translate that with, let's see, translate new lines to spaces. Yeah, that'll work. Docker stop all of these. Hey, there we go. Nice. Awesome. Let me go say that as a little helper script real quick. Stop docker browsers.sh. Let's go shebang that real quick. Let's do bin. I can type bin bash and then put that in. Boop. There we go. There we go. That way I could just run that script every time I want to stop them. Nice. Nice. Okay. So, because what happens is every time we run this, we leave a dangling browser container in here. So, I wanted to get rid of that. Let's see if there's anything else I need to work on here. Actually, I need to run to the restroom, so I'm going to go do that real quick. And then we'll keep working on this, so I'll be right back. All right, I'm back. Let's see if this screen capture crashes again. Now, will it recover? Let's see what happens. I think it's saying no. Wait, there it goes. So the reconnection did happen. Nice, very nice. Have you heard of or looked at Joel's server Linux successfully ported to run directly inside a web browser. No VM or cloud, just WebAssembly. I have not heard of that. That sounds wicked. Blaise is taking a file dump. I wasn't pooping, man. I give Oni crap all about that all the time for starting the whole pooping meme. I think I do want to take this out, actually. Yeah, I'm just gonna do it this way. That's gonna be a string, that's gonna be a string. Just like that. Okay, what are you complaining about that there's a typo in here? Nothing. I don't want to rename it to anything. I just want it to be long-term memory. Stop telling me that it's typoed. And I'm going to take this out because this was a good idea. But honestly, if I need to keep track of the messages, I'll just take the output from them. Blaise never poops. That's right. Pooping is for the weak. Only here just in case it's needed. I'm gonna put another note in here. This is used for routing to primary agents. All right, so now that we have a working memory and a long-term memory, what we want is, I want to make the revisor take that initial access exploit that comes back and pop that over into there. Because then what should happen for the next run is it should come back to the working memory and read the initial access exploit and then use that sucker. Okay. So down here in the revisor, where do we want to do this? So here's our returns right here. All right, so I need to do one more check here. So we have, if the response is validated, we set up all this stuff. We'd have an if check that happens here. No, take that back out. I want to just move those up and reformat this a tiny bit, make it more readable. Because this is one if-else block, and it looked weird the way it was written. So what we can do is, let's see, I'm trying to think how I want to do this. Well, what we could do is we can actually just initialize it up here. Right, so let's come down here. What we'll do is we'll say, I had a new working memory. Hold on. Oh, yeah. Nope, we're going to get rid of that. Because we don't need you anymore. Because we got rid of that. Let's get rid of that. So what we're going to do is we're going to just call this a working memory option right here. And that's going to be a string. And we're going to pull that from the state table. So that's just going to be real easy. That's going to be state working memory, just like that. Boom. So we'll emit the working memory back to it. But if we need to, we'll make changes to it in here. So we'll do one more check in this. How do I want to do this check? Let me think. You could argue that Twitch is a social network, but I'd rather see it as a remote co-working space. That's really more the way I see it too. Although it depends on, honestly, it depends on the streamer, right? Because a lot of streamers, it does kind of build up into a community. Even as we've got Discord where we chat on there, but even then it's more like a little bit like co-working. Hey, we're checking on stuff, we're sharing memes, we're talking about the things we're working on, asking for help with things we're working on. So it is a bit more, I guess you could call it social co-working instead of social media. All right, so here's where it checks for the step failure. Checks the step status if it came back as verified. Ooh, there's another thing we're going to have to change, actually. We're going to have to go change the prompt for the reviser. So here's where we check for the failure, and this is where we actually get the prompt. Here we go. We need to change the definition of the initial access exploit because we've changed it in the working function now. So for determining the create initial access exploit to the target task, output should be complete and functional Python code Oh, it doesn't necessarily need to be Python. We've actually expanded it to where it could be other things in here. Right now, it's likely it's going to use Python. Let's see. We'll just take out Python. Let's see. What would we call that? Maybe like a structured tool call in here? Let me think about this. So those are exploit tool, those are exploit code. Yeah, we could just tell it it's going to be a structured tool call. So we'll just take this out. We're going to insert it down here. It should be or structured tool call with the say name and args. There we go. And we'll just take out the code part right here. So initial access exploits may contain placeholder values like command. This is to be considered valid. Okay, there we go. So we'll update the prompt and then we can come back over here. So we get all of our data back, then we go into the validation loop. So if it's validated, so this is if we had, this is the early RCE check. So actually we could do this before the early RCE check. That would be fine. Because what we would do is, we'll do one more check here. So we'll say, commit the initial access exploits to working memory. I think that would work. I think it would help if I spelled initial correctly. I keep typoing it. So what we're going to do is we're going to check and see if... We want to see if this is our second to last step. So we'll say if... And we can just use this right here. So if the current step is equal to... Actually, that should be a double equals. If it's equal to the length of the exploit steps... Do at this. -1. No, that would be the last one. So we want to do a -2. Basically, what we're going to say here is we're going to check if we're on the second to last step right here. So if the current step is equal to that, then what we're going to do is we're going to say assume working on crafting initial access exploit. Right here. And then what we're going to do with that is... So once we're working on that, we want to take the output from this. So we're still going to need to return whatever AI messages we've got here. Actually, I think the AI logging in here is pretty bare. We don't, I'll have to go buff it up because it's kind of wonky right now. Mine does that all the time, Tigra. Yeah. You're really excited. And I actually was thinking about something and I was like, oh wait, that's not gonna be useful. I just got really excited about it. So if we're on the second to last step, let's assume it called either of these two PHP functions right here. The get initial access exploit code or get initial access exploit tool call. So if it calls either one of these, what we want to do is capture that tool call output. No, hold on. I lost my window. Wait, no, I'm in the right window. I'm just tabbing over to the wrong thing. So the way we're going to do that is by looking at the messages. What do we use it for the context here? I'm trying to remember. Oh, it builds the exploit task context. That's right. So our task output is... We could actually use the task output right here. That'll format our tool output. How did I define that? Yeah, I think that'd be fine. So actually, we just use the task output. We just write the task output over to... Yeah, I think that'll work just fine. We can be a little bit... It doesn't have to be exact. We can be a little bit freeform with it because we've got the language model processing it. So what we could say here is we want to go to state... Actually, we can just say working mem. So working memory is going to be... We'll just do a format string on this. And this is going to be our... We can just reuse these two variables up here. The task and the output. So we'll do step task and task output right here. So we'll do step task. We'll do a new line. And then we'll use task output, just like this. Boop. So what this is going to do is it's going to put that into the working memory. And then, actually, this works out really well because all we have to do now with this current piece of information is now we just should just update this. So we say, we'll say working memory, and that's going to be our new working memory, just like that. Boop. Actually, there should be one other thing that happens here. We want this to actually be a plus equals. Just in case there is something that's going to be using the working memory in the future, we want to throw that into it. I don't think that's going to be a problem. Yeah, because we initialized the working memory up here. So with the working memory, so yeah, that'll just append it. We pull it from the state table, we modify the local variable, and then we emit the local variable, which is perfect. That's what I want to do. There's some wild music too, Bob. Yeah, I think that'll work. Okay, so now what we've got is we have the initial access exploit dumped over into the working memory. This is going to be interesting whenever we get through this. And then now what we need is we need the special agent to process this differently. So let's go back up to the step processor. We need the step processor to actually handle this a little differently in here. So we need to actually put this check in right here. I gotta remember how I did this real quick. And this actually should fix our to-do up here of fixing the cheating method for it. So we pull out all of our relevant information. We come over to the prompt template. We then invoke it. Let's see. Oh, this is just our list of our special agents. So this is saying this is what we can run. Here's the step. Here's the context. Okay, so we need to actually have this fire before here. So the step task and the context are actually going to be what changes for this. So I had these right next to each other because they're working on each other. But I think what I'm going to do is we're going to move this up here, move this down one, because these are going to change right here. So what we're going to do a check here. We'll say check if on the last task, which would be that's going to be testing the initial access exploit. So instead of doing the context where we build the exploit context, we don't care about that. So that's the more frequent one, right? So I'm going to put that one first. So if... where did I do that? Did that down here. I'm just going to copy this code real fast. I'll just come back up. I don't remember what all I was doing with this. There we go. So what we'll do is we'll say, so if the current step is equal to the last step on here. Actually, we'll say not equal. Then we want to do this stuff right here. And then we'll put an else step in here. Meaning that it is equal to it. So in that case, our context is actually going to be equal to our working memory. Yeah, we'll say state working memory. Step task will still be the same. But I think what we might do actually is modify the prompt before we call this. So what we're doing is we're getting, actually there's our prompt template right there. Oh, yeah, I like to keep these together as well. However, I need to bring this up here. So we're going to modify the prompt template. And what we're going to do is, let me go look at the prompt template real quick. Okay, we need to modify this one too for the exploit template. Let's see, definition, initial access exploit. Yeah, we got to modify that too. I want it to match the definition we used before. No, we don't. We didn't define it down here. Up here, we did it differently. So we actually defined a definition for the initial access exploit, because that's what it actually needs. It will auto-generate the required code. Okay. So the initial access is a single Python as a code to replicate an exploit for executing a single target on a task. Okay, this will still work. We just need to change this part. So the initial access exploit is standalone code or tool call. Let's see. Let's kind of pseudo, we're going to kind of pseudo mark down this. So it's a standalone code or tool call to exploit the target. Or executing a single command. Let's see. Yeah, we'll break this up just a wee bit here. I'm going to put in another so we'll say look for tool names that contain initial access exploit that will auto-generate the required code. Actually, I'll tell you what, I want to move this up one right here, because what I want to tell it is that this could be a so we tell it the definition is a standalone code or tool call to exploit the target for executing a single command. I want to tell it this could either be a code or a tool call. Actually, now that I think about it, we can just tell it that. Let's see. We'll say if the initial access exploit is code, called the, what did we call that tool actually? Was it called Python exec? I have to remember. I think it's under utilities, file systems, web. No, that's not it. Oh, it's under coding. There we go. Python exec. Yeah, it should be codename _exec. All right. So we're trying to tie all these pieces together. So when the language model goes and does its little vectorization and math, it kind of groups these things together in a closer hyperdimensional space. We're trying to drive it to put the ideas together as best we can. Hallucinations and randomness will still bite us in the butt, but we're trying to reduce those as much as possible. Call the we'll say call the function named with the language and ending in _exec. There we go. We'll just be blatant with it. And then for the other one, we'll say, so if the initial access, I can't spell, initial access exploit is a tool call. Let's see. Call the tool by name and supply the appropriate arguments. We'll just say that. Appropriate. Yeah, we'll say that. Actually, I'm going to do one more in here. Say, substitute the command parameter substitute the command placeholder for the appropriate command. There we go. There we go. For the actual command to run on the system, on the target. There we go. Excellent. I just broke it by fat fingering it. There we go. All right, so hopefully with buffing these prompts up, it'll work. So we tell it, here's what initial access exploit looks like. So look for tool names that contain this. If the initial access exploit code is code, call the function named with _exec. If it's a tool call, call the tool by name and supply the appropriate arguments. There we go. And then substitute the command placeholder for the actual command to run on the target. Boom. So now with this happening, what we're doing is we're modifying the tool call here, or we're modifying the call to the language model. So if we're not on the very last step, it's going to do the normal stuff right here. Bam. However, if it is, we're just going to inject that working memory that we got from the previous step. So this is step N, right? We have steps 0 through N. We're on step N. We set the working memory on N-1. So now it's going to check N-1, or it's going to check to see, are we on step N? And then it's going to fire it off with the working memory as the context. So rather than having a list of all the steps taken for the exploitation, we're going to limit it, the knowledge that it's got. Each of these language model calls is really atomic, if you think about it. They're self-contained. We give it the illusion of continuity by controlling what information happens between the calls. So if I send the same call and then I tell it, what did I just ask it? Or if I send a call, right? I'm like, hey, what's the weather in San Francisco? It's going to return data. And then if I ask it again, what was the thing I just asked you? It's not going to have a clue unless we take that output and we supply it to the next call in the conversation. So if you're ever working with a language model, like something like either OpenAI or Claude or Grok or whatever, Gemini, if you're a masochist, then all that happens where it sounds like you're having a conversation is because the data from the previous questions is being fed into the language model. And occasionally you'll hit a step where it says, the conversation's too long, I can't keep working with you, you need to start a new one. Or they take all that data and they compress it and they try to summarize it so that you can keep working with it. But then you usually get data loss when that happens. So there's a lot of trade-off here as the things go back and forth. I think this will work. Let's see. Nice, I like this. It does not fix the issue. It might fix this one here where it's cheating by using the call PHP Web Shell Diceco, but that's fine for some of it. I think it will fix this issue. It's not going to fix the issue where when we hand back off to from the loop back up to the exploit agent, it's not going to fix that issue. That's another one that we'll have to fix. But I'm trying to buff this guy up here where it looks legit. We'll have to add one more probably modification to the step revisor to get that back over there. Let's go run this sucker. Let's see. We need to go back to Stinger, and we have to run this with the test data. Let me go get that real quick. I know. Dude, Ty, so many of my coworkers, they love getting the Monday update on what happened with HackBot. It cracks me up. Because we have we got a chat in the work chat where it's like, hey, this is what this is everything going on around like large language models and data learning, right? So as we're going through this, what I'm telling them is I give them updates in that channel of, hey, here's all the stuff we did over the weekend for HackBot. Are you gonna run? Submit. No, there's probably an error in the code here. Hold on. I can see the error up here. Something's going on with this. Oh, hold on. What is the actual error it's throwing here? Oh, it can't find it. Well, yeah, it's because we deleted it. All right. So now it should hopefully hot load in. Oh, I'm all the way at the top of the chat. Here we go. There was the error I was looking for. Couldn't hot load. Failed exiting. What's the issue now? Oh, there's another one where it... Stinger agent can't import working memory. Ah, crap. All right, where are you, Stinger? Wait, was this guy... Ah, damn it. I didn't mean to do that. Wait, why was Stinger using working memory? I don't think Stinger was using working memory. In fact, task list it's not even using. What is this, line 5? There's nothing in line 5. An agent, Stinger agent, module, Stinger graph config. Hold on, where's the actual issue popping up here? Wait, why is the special agent loader failing? Oh, you are killing me. Was the special agent loader using the working memory? No. No. Surely you weren't using working memory, were you? No. Browser wasn't using working memory. I know for a fact. So its special agent loader failed because... Oh, it's in context helpers. Duh. It tells me right there. I'm an idiot. In fact, I can take this out too. Do a little bit of code cleanup. There we go. Now will you build? Line 54, an initializer state context? What? Why is the initializer having trouble now? Hold on. I'm going to kill the server real quick. You die. Restart. See if I can get a little bit of clean output for this real quick. Okay, I don't think it had a problem with this now. Because we didn't change... Hold on. In the states table, we still have our context in here, right? Yeah, there's context right there. Key error on context. I don't know why it had that. Okay, now the downside is that nuked my test data. Copy that. There we go. And now I got to get the IP address again. There we go. Looks like because of the a bunch of the changes that we made to the code base, because we're making a lot of disparate changes, it probably didn't know how to quite hot load all those in. I probably should go add a specialized, maybe using like libnmap parser for the XML, because man, it's junky. Because right now what we're doing is we're sending the entire XML output, and it is huge. So it's just burning a lot of extraneous tokens. We should be able to... Well, that's not good. What was the error we got? Runtime error. So we had a problem in Recon's host update. What's wrong on host update for Recon? I just broke everything with this change. Oh no, did I delete tool message? I bet I sure did. Wait, why is that saying that's an error? That's a weird import error. Hold on. Because I didn't change anything in Recon. Why is it all of a sudden not able to see the tool message in here? That's wild. All right. Let me go check the Recon. That was Recon. Let me check the enum agent real fast. It doesn't have the same issue? Because these two are almost identical. So why did tool message get deleted out of Recon and not out of enum? I don't know. All right, well, let's try it again. New thread. Run again. Run again. Damn it. It ate my homework. Let's drop this in here. There you go. That way I just have one place to copy and paste. Normally, I don't have to run this so many times, but since we've made a lot of changes across the entire code base, I do need to run it. So we'll see what happens, because host update is where it failed that time. At least that's where it was saying it failed. All right, so it looks like it did the nmap scan. It's formatting it. I'm still thinking also about the quartermaster. Damn it, it had the same error. Even though it looked like the only error was with the tool message. So where did this error out at? It errored out in the host update. Let's see. During task host update. Util states initial access exploit. Error checking inheritance of slice. Oh. Aha. So what it's saying here is that in the states table, the initial access exploit, it's trying to format everything together, and it's running into an error here. I see where it's saying it was having trouble with the host, so I know what's going on here. Where's host? Does it not like this annotated dictionary? Because we did update this. We updated it saying, hey, by the way, now you're going to be a dictionary with type int. And the integer should be the port. Let's see. Let's just change this from exploits. Let's see. This will say maps port to an initial access exploit. So the code compiles correctly, but I've never done this before, right here, where it's annotated in this particular way. All the rest of these were already annotated. This one's a bit weird, though, because it's a dictionary. Let me see if I can time travel that and maybe run it again. Actually, I don't know if I can. You're not going to let me, are you? All right, new thread. Run. Let's see what happens. So what's happening here is when it does the host update, it's trying to think how to return it. And it doesn't know what to think about it, is what's happening here. This is a weird problem. Of course, I completely broke it. Error checking inheritance of a slice. It's because we did not. Let's go look at the code for that real quick. Because pretty much if the recon agent's having this trouble, the enum agent is going to have the same trouble over here. Bring this up here. So it's not in the output formatter. It's not in the validator. So it's in the host update function here. So I don't think that's in, I gotta remember, because I haven't worked on the recon agent in so long. Where's host update? Oh, host update was, I forgot. We had made that its own special utility. Yeah, that's what it is. Okay, so it's happening kind of in here. That's what it is. Return host, initial access exploit. This should just be, I think this is the problem here. It should just be a blank dictionary. I think that might be the issue. Yeah, so for get stub host, that should be a dictionary now. But actually, it's up here in this one that's happening. So let's go take a look at this. So we get the tool output, we send the host, we send it, we want to do a structured output for a host entry. And the host is defined over here. So it's having trouble with this structure right here. So what would be the issue with this? Maybe I'm just, because my understanding was this should map, it's saying, hey, the key is going to be an integer and the values could be, now this is the first time I've done this, so I don't know if I've got this correctly. Let's see. Type int for a dictionary mapping, let's see, int to an object. Yeah, so it should be like this. Maybe it needs to be a capital dictionary, capital D. Actually, no, this is for 3.9 plus. We should be able to do lowercase dictionary. You know what I just realized? It's because it's a colon. It's supposed to be a comma. So this was technically correct. There we go. That was technically correct syntax, but it was not what we wanted for correct syntax. Let's see. Hey, Drewski, what's up, brother? Happy Sunday, man. All right, now that this is fixed, let's go try running this again. All right, back to square one. Let's go back to Stinger and try this one more time. I was trying to see, how did we break the code in that section? We didn't even modify it at all. All right, so now hopefully the host update node now, which you can barely see, will function correctly. Eventually, probably when we get ready to do like the code rewrite, the recon and enumeration agents, since they are so similar, I may abstract those out and make it like a single type of agent that can work in there. Hey, we got past it. Yay. Because then what I could do is I could say, okay, the recon agent is a copy of this object with these parameters. The enumeration agent is a copy of the same object with just these parameters, and then let it go. That way, instead of having to like mirror changes and mess with it, it could just be like the one. We have like one code base to do it. This one, like I said, enum didn't have any issues. There was one weird issue with the recon agent missing the tool message import. I don't know how that happened, but it looks like it's running okay. Sweet. We'll watch the exploit agent really carefully once it gets down. Actually, once it gets to the exploit agent, I'm probably going to kill it. I'm going to make it stop. And then we'll just run the exploitation agent by itself. Because I want to be able... I can't see like what's happening internal to the graph here very well when I'm running it from the parent graph up here. So I want to be able to dig into it really closely. I'm a Rust noob now. We were just... I don't hate Rust, let me say this, but we were ripping on Rust earlier. A little bit. Mostly because we were joking about a lot of the non-memory bugs that are still security vulnerabilities that get introduced in rewriting old utilities in Rust. Oh, that's not good. Something died. So for example, we were talking about the Rust version of sudo that had a logic bug in it. Oh, that is not true. You did not finish whatsoever. Hold on. What happened? It hit the exploit agent and just went boop. Oh. Well, hold on. Load pickles should have started with our inputs, and then what was the output from here? Well, that should have been fine. I wonder what just happened, because it just went, it sped run this and said crash. What the heck just happened? Oh. I think I know what happened here. There's a logic check to see if there is an initial access exploit. in the exploitation agent, which is fine. It hit the pickle function, so it saved it to memory. However, here's what happens. So when it hits the exploit agent here, by the way, Drewski, the whole thing about Rust was largely around a lot of people in Rust wanting to go rewrite old stuff that's been battle tested in Rust. So we were kind of ripping on it earlier today, but don't let that dissuade you. If you're liking Rust and you're enjoying it, more power to you. I can't stand Rust personally just because the syntax is so foreign. I tried. Actually, I went in and was trying to add a feature to RoboPages, and the whole thing's written in Rust, and I failed abysmally. So I do think we need more people writing Rust. I just think they should be writing new stuff instead of. And if you're rewriting something as an exercise, that is totally cool. Or to improve something, that is totally cool. But operate within the proper scope, you know? So what happens here is, I know what happened. The exploitation agent, it checked, did we have an initial access exploit? And then it set it to the exploit validator, which we actually don't need. Come to think of it. This should actually be taken out. The exploit agent needs a lot of work over here. That's the plan. Good plan, man. And sometimes it's handy to have tools that kind of have the same functionality, but they're written differently by different people. So I can't tell you how many exploits there are, or not exploits, but like different tools there are written in C# versus Python versus C++ that do the same thing. But I cannot tell you also how many times that the C++ version has failed and the Python version worked, or the Python version failed, but the C# version worked. So having that larger arsenal is always super handy from my perspective. Blaise hates RustScan confirmed. I don't hate RustScan. I think RustScan is okay. At the same time, I just usually stick to Nmap because Nmap has a lot of battle testing to it.
Hello, IT. Have you tried turning it off and on again?
Several times. We just finished turning it off and on. I spent a lot of time window shopping between languages to sit down and learn. I had to choose one. I'll tell you this. One of the good things about picking Rust as a first language is, one, it will make a lot of other languages seem really simple. But the other thing is, I recommend anytime somebody picks a first language to learn, pick a strongly typed language. And Rust is a strongly typed language, meaning once you define a section of memory and you say it's an integer, it is an integer forever and ever until the program ends. Or you say it's whatever other type. It has to be that type. Whereas Python, you could create a variable and say, this is an integer. All right, now I want to cast this 1997, Toyota Yaris as an integer and stick it in that memory spot. Or just say, you're not an integer anymore. Now you're a 1997 Toyota Yaris. Whatever. It doesn't care. All the typing that I'm doing in here, like where I say, by the way, this response is a host object in here. That's just this is not enforced in the Python code at all. This is for the benefit of the IDE here to know and tell me when, hey, by the way, you're putting the wrong variable type in here. This function returns something and it's not this type. Those two don't mesh. That's simply for the benefit of me as the developer. Rust does go burr, yes. Barox Buster goes burr. All right, let me go over to the exploitation agent here. So we need to change how the exploitation agent checks things because the type has changed in here. So we defined load pickle, that's great. So down here in the exploitation agent, fix what happens during successful exploit. It's borked. Yep, I know I still need to do that. Okay, so pre-flight check right now is bunk. We will still need the exploit validator, actually. Okay, so first thing it does here is we check to see, is the current task, if the agent is set to exploit. Because when this comes to the exploitation agent, the task right here, it is a type of task. You notice how we don't have anything specialized for exploit. What happens is in the task, the output actually holds the exploit task in here. So again, all this typing is just for our benefit. I'm gonna change that to a lowercase dictionary because we don't actually need dict from typing anymore. Where is this used? Hold on. Oh, that was not what I wanted. Hold on. I know a way to fix this. Take you out. And then where does it break? It breaks here. So that should be a lowercase dictionary. And these two down here, that should be lowercase. And this one should be lowercase. Since we're using Python 3.9, we can get away with that. Hey, Void, what's up, man? I chose Python months ago initially, but I felt like I was doing too much for me and I wanted to feel like I had more control over what I was writing. Dude, I think that's a good point, actually. Python is very handholdy. Honestly, the only reason I picked Python for this project is because I already had the framework picked out, and the framework is already only implemented in JavaScript or Python. So we're like, all right, cool, we're doing some Python. All right, so here's where we initialize the check. Let's see. Oh, I can take this out because this code has been... Oh, God, go back. Let's clean up a little bit of this code in here. So this can go away. So if the state's validated, that's what it's doing. So as long as the attached string is not none, then it goes and it puts it all together. Where do we actually send it to the exploit validator? That's what I need to double check here. Hey, night caffeine, man. Have a good night caffeine. Have a good night, caffeine. Now I'm picturing you in like medieval armor. I am Sir Caffeine. Let's see. Oh, so here we go. So we set the pre-flight check to true. Oh, here we go. So if this equals this, then we're saying no initial access exploit available. Else, we say it's validated, and then we go to this. And see, this is what I'm talking about right here. Expected type literal validated. Do I need to make this a literal? Here where I tell it, hey, by the way, you're literally... I'm going to try this, because I have so many of these. I don't get why it does this. We expected this. We did not get that. It is validated. I don't get why it's expected this and got a type string. Hold on. Let's see. PyCharm. Type checking against literals. Nope. Python will forgive the convert for the variables. It'll forget you about your space. It'll accept multi-threaded runs. Yeah. Let's see. So to use proper type checking, it's recommended to use explicit annotations. So for example, using literal in the function arguments. Type checking against... I misspelled literals. Let's see. Type checking against literals when assigning variables. Because I want it to realize, hey, this is... without overloading it. Because what it's giving me is it's giving me, let's see. What is this error here? Shut up, baby. I know it. Literally. Exactly. Actually. I don't get why. Alright, let me just try this. Python. Expected literal got str instead. God, my typing is horrendous. There we go. Let's see. Issues often due to a known bug in PyCharm's type checker that fails to correctly handle literal types. Workaround suggested by the community is to use cast from the typing module to explicitly cast the value as the expected literal type. This literal string was introduced in PEP 675 to represent a supertype of the literal string. String constructor does not produce a literal string value. So how do I... Good old Stack Overflow. I just have to use the byte separator. That's not what I wanted, though. Interesting, though. Cast spell charm, Vista's start button is still called the charm. What? Really? Because this error, like, so when I'm looking at the code, you see all these freaking lines right here? A lot of times it's because of crap like this, where the type checking is like, hey, this is supposed to be a literal. What do I do here? No, that's not working. Alright, I'll mess with it later. It's just bugging me. Anyway. Oh, I needed to actually go through and test it. That's funny. So this is the part that needs to change right here. We need to make sure that if the initial access exploit is equal to... Actually, what I want to do is, let's take... Let's go ahead and bust that out. We'll call this the IAE. That's going to equal this. So we'll say if the length of the keys in here. So what we'll do is we'll say if the length of the IAE.keys. Yeah. I think I have to make that the function call. Is equal to 0. There we go. Put another 2 in here. Actually fix this to test the IAE. Yeah, I know. It's misspelled. Okay, so now hopefully it shouldn't just bypass the initial access exploit. How much time we got left? I want to at least get one run on this so I can see what it's doing tonight. Oh, I don't think it liked that something in here failed. Oh, did I miss one? Hold on. Yeah, I missed one in here somewhere. Yeah, that should be lowercase. There we go. Since I'm cleaning up some of the typing in here. Oh my. A lot of stuff just flew by there. Exploit handoff. No, you shouldn't be doing exploit handoff. New threat. Well, they just sped run it again. So there's the initial access exploit. So the exploit router is actually something that's giving us trouble in here. Because this is our conditional jump right here, right? To exploit validator. So I need to go find that real quick. So where is our exploit router? Because we hit the exploit router, it didn't know what to do with this. Check current task pre-flight check. Okay, so the pre-flight check never got set, which means the exploit agent is doing something funky here, where it's not setting the pre-flight check. So let's look at the current task pre-flight check. So it gets the current task, double check, does the pre-flight check. So going into this, let's go take a look real quick. Actually, the best place to look at is the output from the pickle function here. So for some reason, step 5 got validated on the output, the exploit task. Why are you validated? That is absolutely wrong. How did you get validated in here? Thoughts about the AI bubble? It's going to be big when it bursts. It's going to be real big. And that's expected though. So I don't know how old you are, but I'm 41. I've seen boom and bust cycles in multiple industries in those times. So it usually happens either for one of two reasons. Either there's an incestuous relationship with money just going in a circle, like we're seeing now, or there's just a lot of hype and the money flows into something and nothing comes back out and it just evaporates, right? It doesn't really evaporate. What happens is it hits a point where the returns from the companies don't justify the investment. And there's an old saying also that, hey, the markets can stay irrational longer than you can stay solvent. So let's say you were on the short side of that and said, hey, I'm going to bet against the AI bubble. Well, I've been there. I've lost money doing that. The market can absolutely stay irrational longer than you can keep paying to play the game. You're so old. That's why you poop on stream so much. Very old. I just want you to know, Cypher, you're my #1 fan. number one. So where did this get validated? That's wild. Where did this hit this? Let me look at this one real quick. So if we look at the input for load pickle here, current task is 5. So we're looking at the input here. It's status new right now. Okay. So then if we go look at the output, it should still be status new. Still status new. So this should have been the data that got written to the pickle file. That's very, very weird. Let me see if I can edit the node state of this. Oh, that's a lot in here that I gotta scroll through. Where's the actual state table? Current task 5. Okay, so this should not be validated. This should be new. Fork it. All right, so somewhere along the way, we got some kind of like data corruption in here. Let me see what the step planner came back with. Hopefully it came back with good steps. Let's see. Navigate to the upload form, upload the PHP web shell, access the web shell, test execution, and then we'll have our 2 injected ones at the end there. Nice. Without investments in data centers, the US GDP would have been 0.01% for the first half of 2025. Damn. GDP growth of what I think you're saying, but yeah. Seems like an unsustainable path if the ROI isn't proven for how long it is in question. Yeah. I just think of the example of Taco Bell wanting to do AI ordering boxes, right? So you pull up, you're going through the drive-thru at Taco Bell, and rather than talking to a person, you're talking to a voice-enabled chatbot, right? And people got so fed up with it, they found a workaround. They go up and they said, yeah, I'd like 8,000 cups of water. And it panics the AI agent and it immediately dumps them to a person, and then they just place their order like usual. And that's the way I think about it. How much money do you think Taco Bell is saving by trying to replace the people at the drive-thru? Probably nothing. That's just one example of many, many, many examples. There's too many companies that are trying to early adopt all this stuff. They're trying to come in and say, hey, we're going to just slap AI on freaking everything, and it's going to make it instantly better. I was like, I'm sorry, man. AI right now in its current iteration is not ribeye steak. You can't just slap it onto anything, and it instantly becomes better. All right. Unfortunately, I think that's where we need to wrap up, especially since the box only has 3 minutes left on it. So let's go find somebody to raid over to. Getting so close, but these are very important updates to make to the exploitation agent to get it functional again. Not to just get it functional, but to get it so it has scalable functionality. I want it to be able to handle multi-box systems in the future. So by doing these little bits of testing and updating now, we're at least preparing for that, even if it's not working right now. Let's see. Who's on InfoSec streams? CyberDoc is on. What's he working on? The reliability and consistency just aren't there. It's not good enough, even at a 90% success rate. Right. Let's see. What's he working on here? Day 52, hacking with Burp. Might go give him a raid. Let me see who else is on right now. see, same category. Spinning up a new Godot HUD list server to automatically for each match. Ooh. Pirate's Guide to Unreal Engine 5. Let's see. Not sure who else is actually working on stuff right now. Let's see. Adam's on working on his game. That shall. You know what? Let's go see who's over in science and tech because there's so many folks over there. I do love my science and tech folks. By the way, when speaking, damn it, I closed it. Speaking of the AI bubble, Wednesday night we're going to be covering Anthropic's report during the news stream about what happened with them busting up that super hacking group as they're claiming it is. I have a lot of doubts. A lot. I haven't messed with AI with Claude Code very much, which was essentially the system they were using to make it agentic. But it is there, right? I get what they were doing with it. It relied on a jailbreak of Claude, which I think is really funny because I have some thoughts I'm going to save for the stream. I need to double check something actually before that stream, but yeah. Let's see. Let's see. Braithorn's on. Maybe we'll go right over to him. He's doing stuff. Let's see. We also have Astronomy Lady doing rocket launch. Moo hoodies. Let's see. Let's go right over to Zetashot because he's doing some fun stuff. Actually, hold on. Let me see who else is on right now. Moonwood's on. Nate's learning some Godot. Yeah, I think what we'll do is we'll go right over to Braith. Because he's always good for raid. Oh, Science Stream is also on. Ooh. Yeah, they're always doing fun stuff. Yeah, let's go right over to the science, guys. All right, everyone. That's where I got to wrap it up because I got to start a new project tomorrow. Everyone, y'all have a fantastic week. If it's already your Monday, I hope you have successfully initiated Crushing It mode. For everyone else, get some good sleep because Crushing It starts early in the morning. The sun does not dictate when Crushing It mode starts. It starts when you wake up. Wait, hold on. Nerduino is playing Arc Raiders right now? No way. Hold on. Hold on. I did not see Nerduino online. He is online. Okay, I'm going to go raid Nerduino just because I love Nerduino, so we're going to go hit him up. Guys, do me a favor. When you get in there, though, drop a bunch of Hack the Planets in there. Because I haven't seen him online in a while. I wanted to go. I wanted to raid over to him, so that's perfect. Oh wait, we're done. Finish the sign off. Crap. Take care, guys. I love y'all. Peace.